Hey, it's Christian with the second screencast assignment for chapter 10, where we were given a video of a plane and we were asked to find its rotational velocity, mass, and the length of the string that it was tied on. So here I just drew a quick diagram, which is basically what the video showed, and then I wrote what we needed to find, our givens, which was the tension on the string, which was constant at all times, and it was 6.5 newtons. The rate of frames, which was 120 frames per second. I counted the frames of one revolution that the plane did, and that was 144 frames. And then I wrote down some of the ungivens, which were time, the centripetal acceleration, stuff like that. So I started off by finding time by just dividing the frames by the frames per second, which was the rate, and that gave me 1.2 seconds. So that's how long the plane took to get across from one end to the other. And then I used this formula, the 2 pi equals omega times t, to find the angular velocity, and then that was just 2 pi divided by 1.2 seconds, and that gives you 5.235 radians per second. And then the next thing I did here, I just showed that there was no translational acceleration, so because centripetal acceleration is equal to delta W over T, and so that just proved that there was none, which comes in handy later. Then next thing I did was solve for the mass, and then I just broke up the components, and first I solved for the y component, and then the sum of all the forces in the y component is equal to the tension minus the weight, and then if you solve for that, you get that the tension in the y component equals the weight, so Ty equals mg, and Ty, here we did a little trig, and Ty is just the cosine of the angle times the tension, and that gives you roughly 3.9, and then you divide that by gravity, which is 9.8, to get your mass, and that gives you 0.399 kilograms, and that's the mass of the plane. Next, I solved for the length of the string, and this time we did the x component, so the sum of the forces in the x component equals the tension in the x direction, so then that just and then the force equals mass times acceleration. In this case it's centripetal acceleration, so 0.4 kilograms, which is the mass of the plane, times the acceleration equals the tension in the x component, and we just did a little trig again, and we found that the tension in the x component is 5.19 newtons, and then we solve for the acceleration, and that gives us 5.19 newtons divided by 0.4 kilograms, and that gives us the centripetal acceleration here, the 12.98 meters per second squared. And then lastly, we just use this equation, the alpha equals radius times omega squared, solve for the radius, plug in our values, and you get that 0.47 meters equals the radius. So then after that we do a little more trig, because the radius isn't exactly the length of the string, so we do that the sine of 53 degrees is equal to the radius divided by the length of the string. We solve for the length here, and we get that the length of the string is 0.59 meters.